Hey folks, how's it going? In this video we're going to go over question 4 from the 2015 SQA Advanced Higher Physics Exemplar paper, so let's get started. Question 4 says, on a trip to a theme park, a student described what happened in the fairground spinner shown in figure 4, and they said you get thrown outwards by centrifugal force, you can feel it, it pushes you into the wall, and there's the fairground spinner there. And it says use your knowledge of physics to discuss this statement, and you'll see there's 3 marks available here. Well, remember, for a using your knowledge of physics question, your answer does not need to be excellent or complete in order to obtain full marks. And I'm going to go through some possible answers that you might want to include here. So firstly, we could say the student's description of being thrown outwards by centrifugal force and feeling pushed into the wall in a fairground spinner is partially correct. We could then explain what centrifugal force is. Centrifugal force is a perceived or apparent force that appears to act outward on a rotating or accelerating object. It is not caused by any physical interaction between objects. It is experienced from the perspective of an observer in a rotating reference frame and is actually a result of inertia and the object's tendency to continue moving in a straight line. And in the context of a fairground spinner, the spinning motion of the ride creates the sensation of centrifugal force. And we can then go on to explain centripetal force. So it says when you're inside a fairground spinner, the ride's circular motion causes an inward force acting on your body, known as centripetal force. Centripetal force is the real force that acts on an object moving in a circular path, keeping it continuously directed towards the centre of the circular path. It is responsible for the centripetal acceleration of an object, which always acts towards the centre of the circular path, enabling it to maintain its circular motion. In this case, the fairground spinner's walls exert the centripetal force on your body, preventing you from moving in a straight line and instead keeping you moving in a circular path. And going into a bit more depth about centripetal force, we can say that as a result you feel a sensation of being pushed into the wall due to the centripetal force. This sensation arises from the fact that your body tends to move in a straight line due to its inertia, which remember is the tendency of an object to resist changes in its motion, but the ride's walls continually exert a force that redirects your motion towards the centre of the circular path. And we could then give the equation for centripetal force from your relationship sheet. So we can say that centripetal force depends on the mass of the object, the linear or angular velocity of the object, and the radius of the circle. It can be calculated using these equations here, F equals mv squared over r equals mr omega squared. So you can either say that F equals mv squared over r or F equals mr omega squared, depending on if you're using linear velocity v or angular velocity omega. And we can state what each of these symbols mean with their units. So we have where F is centripetal force measured in newtons, m is mass measured in kilograms, v is linear velocity measured in meters per second, r is the radius of the circular path measured in meters, and lastly omega is angular velocity measured in radians per second. Looking at the two equations, we can then look at how the variables are related. So we could say that since the centripetal force F is directly proportional to the mass m, the greater the mass of the object, the greater the centripetal force. And since the centripetal force F is directly proportional to the linear velocity squared and directly proportional to the angular velocity squared, we could say the greater the linear or angular velocity of the object, the greater the centripetal force. And also, since the centripetal force is directly proportional to 1 over the radius, or another way of saying that is inversely proportional to the radius, then we could say the greater the radius of the circle, the smaller the centripetal force. And lastly, we could just relate this to the fairground spinner by saying that in the case of the fairground spinner, the student's mass is relatively small, the angular velocity of the spinner is relatively high, and the radius of the circle is relatively small. This means that the centripetal force is relatively large, just because its radius is small and its angular velocity is high. Now, it's worth noting that you wouldn't need to state absolutely everything that we've gone through in order to get 3 marks. It's really just to give you an idea of the kinds of things you might want to discuss. That's all for this video, folks. Thanks for watching. If you made it to the end, I really appreciate it. Make sure to give the video a like, subscribe to the channel, and I'll see you in the next one. Take care.